Hey, sorry about that. I had Firefox issues. For some reason, it's not happy at the moment. So, anyway, um, Josh, you were looks like you were starting. What's
Oh,
up, or what are we doing?
we're just getting started, so you can go ahead.
Oh, okay. I'll be frank. I don't have a whole lot here. I only got about halfway through reviewing pull requests, so not a whole lot. Josh, it looks like you merged your off monitor PR.
Mhm.
Cool. That's good. There were a couple of other updated ones. Leaving. It sounds like maybe this OSD async recovery min cost. Now the thought is that we might leave that default. Um, Still a little bit of discussion on that one.
Yeah, last
And
week we found out that some of the tests that were being done didn't have the right crush rules, because of which the results may not be reliable. So we need to wait on that one until further results are ready.
okay, cool. Let's see. And then I think Kifu is still looking at the PR for optimizing the Blue Store write blocks. Uh, oh, that was closed actually last week. I missed that. Okay, but Kifu reopened it. Okay, so yeah, it looks like there hasn't been any real movement on this since last week. It was just closed and reopened. So, all right. Yeah, otherwise, I'm not seeing a whole lot. Were there any PRs this week that anyone had that should be on this list? All right. Well, then, let's move on. Uh, Josh, did I hear right? You were asking Igor, did he have a status update for us?
Yeah, I thought we could maybe start with that and then go into the discussion afterwards.
Yeah, sounds good.
Well, first of all, the introduction. We've got multiple complaints about pretty slow pull removal in Ceph. So it might take several hours to reclaim the space after pull removal, or sometimes I've heard about days. So I did some investigation, what's happening and why it behaves like this, and what can we do to improve the situation. So first of all, let me share some information on how pull removal works at the moment. Can you see this slide?
Yes.
Okay,
Yep.
great. So when a user starts pull removal, which runs in background, SD creates a bunch of tasks, deleting tasks, one per each placement group. And each task works in multiple, performs multiple iterations. On each iteration, it performs a bunch of sub-operations on a limited amount of entries retrieved on the first sub-operation. So this one iteration involves collection listing, which is retrieving up to 30 entries for placement group, 30 nodes, well, their names. After that, it attempts to remove this entry from snap mapper which I'd prefer to leave aside for now. It's not a trivial operation as well, but for my experiments, I didn't have any snapshots, so it was a trivial one. Then on this third step, OSD invokes ONNODE removal from BlueStore, which in fact is a bunch of other sub-operations involving removing all the ONNODE OMAP, then reclaiming all the space at main device occupied by this ONNODE, which is updating BlueStore locator, and then removing all the metadata records for this specific ONNODE. Once completed this iteration for 30 entries, the task sleeps for some time determined by OSD parameter, OSD delete sleep, which is different for depending on the setup. It's 5 seconds for spinner only configs, 2 seconds for spinner plus SSD, and 0 seconds for flash up. And actually, that's the major thing which causes pretty long execution. Imagine 2 seconds per each 30 entries. It takes pretty long time to run through all the entries for, say, 1 million objects in the placement group. Any questions so far? Can you still hear me?
Yeah, I think it's very clear.
Okay. So, well, actually, there are a bunch of issues with this removal procedure. The first one actually is the a bit ineffective collection listing, which starts enumerating entries from scratch on each iteration. We can use previous position instead, and that's easy to implement, and it brings some improvement, but it's visible, but not for the whole procedure. It doesn't bring much benefit. The second issue, as I've already told, it's a pretty large period for sleeping, and that's the major cause which results in long-running pull removal execution. But from the other side, it looks like this is a trade-off to ensure regular operations running in parallel with pull removal to work smoothly and pretty the same performance. I'll show some numbers a bit later. Then the third issue is that this single ONNODE removal is pretty expensive. It involves enumerating of existing OMAPs, which is again some seek, iteration, and delete steps, multiple of them. Then update allocator, and then finally update, remove ONNODE metadata records, again, multiple of them. And that's why we are unable to, well, we can set this sleep period to 0, but it greatly affects the regular operation performance. Even on all NVMe setup. But, well, moving to the fourth issue, it looks pretty strange, but actually for all flash configurations, we have 0 sleeping period, which is different from hybrid configs. But in fact, since we are talking about primarily about database operations, these two setups should be pretty the same, in my opinion. So hybrid setup from database point of view is no different from all-flash one. And potentially we might have some hidden issues, say, for all-flash setup where pull removal might cause a significant performance drop since the default parameter is set to 0 seconds. And the fifth issue is about using more advanced techniques to remove multiple records from RocksDB. Actually, it has delete range function, which might, which is not ideal, to be honest. From one side, it allows to remove multiple sorted records in a single shot. From another side, it actually might cause, as we observed, some performance drop for subsequent read operations. And in fact, currently we have support for this operation, but we disabled it. But maybe we should reconsider this and try to enable it for this pull removal stuff. I'll show how we can update this removal procedure, benefit from deleted range function from one side, and from another side we wouldn't produce that much tombstones which create these functions in database, since actually we'll need just 3 tombstone per each placement group to remove. And the last thing about this delete range operation, which I discovered, not mentioned here, is that at some point we introduced, before using this function, we introduced some records counting procedure to estimate if we want to apply this function or not, which actually iterates over a bunch of records until the threshold is reached. And if we have enough records, then we proceed with delete range, or otherwise we delete using regular function. And it looks like this procedure might introduce additional overhead as well, which is not that small, as I've seen. And again, we might get rid of this stuff. I mean, record counting for new pull removal stuff, and maybe after that, delete range wouldn't be this that painful. Well, in the next slide, I'm going to present the ideas how we can redesign this removal procedure. So, any questions so far before proceeding to the next slide?
No, everything is fine.
Okay. So here is the new design which I'm proposing. I have working POC for that, and well, I'll show some numbers if we'll have enough time for that a bit later. But well, again, well, let me present this this procedure for now. Leaving aside SnapMapper stuff, then what's the main issue with slow pull removal for user perspective? It's well, most of users are uncomfortable with pretty slow space reclaiming when pull is removing. So what they expect is to issue the pull removal and then get some space back to available as soon as possible. And currently, we don't provide that. And maybe we can change our procedure in a way that instead of deleting nodes completely from database, we just reclaim some space for nodes, and then postpone all database removal to the later step. In fact, writing to database is quite faster than removing data from it, and less intrusive in terms of performance. And probably we can benefit from this by doing space reclamation, but leaving objects empty and with all the OMAPs for some time. And so, which is step 3 on this scheme. And once we reclaim all the space, we can proceed with removal, all the records from database. Here are two options, actually. The first one is to leave things as is, which is iterate over every node again and remove them as we currently do by removing their OMAPs, again listing over them, and then removing all the node metadata. But another option might be to benefit from from deleted range function, and in fact can issue just delete range operations on a placement group. The first one to delete all the regular nodes for each PG, which are sorted, and hence we can apply this deleted range. The second one is to delete temporary nodes, which have a bit different naming, and hence they form a different range. And the third one is to remove all the OMAPs belonging to objects in this placement group. Potentially this is possible, but our current OMAP naming format doesn't provide this ability. We need to change the naming scheme to include placement group ID into the naming. And once we do that, we might we will have sorted OMAPs grouped with placement group ID, as we do for ONodes metadata. And actually, I made a POC for that, as I said, and I'll show some numbers about that next step. But any questions so far?
On the last point you were talking about reorganizing the maps, didn't we change them to be organized on a per pool basis?
Well, right now, the last change from Sage brings brought the grouping by pool ID, but it still lacks the placement group ID.
I guess I'm wondering since we're talking about pool deletion, is it possible to delete?
Maybe, but it requires some additional modifications in the code, since currently it operates on placement groups. That's the first issue. And the second issue, potentially we might benefit from new removal from this new removal procedure when we need to remove just a single PG when it rebalance to different host or something. And if we use pool ID, this wouldn't benefit from this procedure. Okay.
Yeah, that makes sense. So it's important to remember that this is not just for pool deletion, but also for removing a PG when it is no longer necessary on a given OSD.
Okay. The next stuff is a bit raw so far. Didn't have enough time to arrange it properly. Sorry about that, but what I have so far. So here are some numbers for benchmarking the original delete versus some tuning on this delete sleep time, as well as for using this reclaim space stuff, as well as bulk removals. What's the scenario for this benchmark? I took all-flash single OSD using the start with 32 placement groups, and then run Radar's bench, which builds this pool with some data to some main data as well as OMAP using block size at 4K. It worked for 1,000 seconds and produced around 2 million objects. Then I do pool removal, which starts to run in the background, and then proceed with another Radar's bench with similar settings and measure how it is affected by the removal, and also measure how long it does take to remove the original pool. And additionally, at the end, for some later scenarios, for some later runs, I tried to measure read performance as well as FS check time to run through the final store, which was an attempt to to estimate how these tombstones introduced by deleted range delete, how these tombstones affect the reading performance. So the first column, which is B, is our original delete procedure with delete sleep set to 2. And here we can, and originally initial performance was at bandwidth was around 7.5 megabyte per second. And on the second run, with full removal running in parallel, we are getting around 6.8. At the same time, the full removal takes more than 1,000 seconds, which is longer than the procedure to fill this pool. Unfortunately, I didn't have the corresponding performance counter on the first run, so I don't have the actual timing, but it definitely longer than 1,000 seconds. Then the next column is about again about original delete procedure with sleep period set to 50 milliseconds, and we can observe pretty visible performance drop for regular write procedure. But at the same time, we can see the improvement in the removal time. So right now it completes faster than the original writing procedure. And the next column about setting this period to 0, and in fact performance is pretty the same, and removal time is even shorter. But in fact, one hidden issue with these numbers is that they show average bandwidth, but in fact, I'll try to show a bit later. Actual bandwidth is varying depending on if full removal is completed or not. So in average, we are getting pretty good numbers for delete sleep 0, but in fact we have pretty low bandwidth while removal is running, which makes it a bit questionable if we want to use it. Then the next column is about an incomplete, a partial fix, which introduces space reclaiming before the removal, but the removal itself is using still the same delete procedure, seek then delete. And here you can see that actually in this reclaim time row, we can see that we are able to complete space reclamation much faster comparing to the removal, the original pull removal, which is good for users since they get their space much faster. But again, some some hidden issues with this procedure is that what's happening while this reclamation and removal is running. Then column F is similar to the previous one, but I added the reading from the pool, from the second pool, after all these removals has completed, and actually that's original performance, read performance we are getting from this pool. So there are no tombstones at this point, and this number shows how fast we are at reading without tombstones. Then the next column, which is not very interesting, it's an updated, a fully updated removal procedure which performs space reclamation and then proceeds with final delete ranges on this placement group. But since it has 2 seconds period, it's still slow because reclamation still operates in these 30 entries portions and then sleeps for 2 seconds. So it's just for us here. It's just for reference. More interesting is the next column, which is H. This is the same reclaim plus bulk removal, and reclaim operates on using 50 millisecond period. You can see it's to some degree faster than our original removal for the same sleep period. We can see also that space reclamation takes 166 seconds, and the total pool removal takes 169 seconds. So we need just 3 seconds to perform all the completion using this deleted range. And the next column, the same, using sleep period set to 0. Well, pool removal runs faster, much faster here. Then the same column, the next column using the same config, and the third column again the same config. And in this run, I had this final reading benchmarking scenario, which is pretty in line with what we had in column F, which is original reading performance. So, well, it looks like from reading point perspective, we are not affected much by this deleted range. One questionable thing is the row 8, which is FS check running after the pool removal. And here I can see that it takes longer with all these changes. Column G to K consistently show longer times. Well, what else I have is some diagrams for how this second writing runs over time in parallel with pool removal. And here the blue line refers to the original delete with 2 second period. we can see it's pretty stable from one side, but it's a bit lower all the time. And again, we don't have space totally freed for this period. So actual the completion of pull removal is somewhere out of this diagram. Then red and yellow lines refer to, again, original delete with different time period, sleep period. And one can see that while pull is removing, the performance of the parallel write operation is pretty low. And that's what probably made the offers original to have this period to raise this period that much. And the green line here is again regular delete coupled with the prior space reclamation. Again, it's questionable. So overall, it provides better performance than original delete, and well, space is reclaimed much faster. But during this procedure, the regular operations are affected, negatively affected. And here are another set of diagrams, which again include original delete, blue lines, and then two new procedures, two new runs with all this new pull removal stuff, where red line is sleep period for reclaim set to 0, and the yellow line for reclaim procedure reclaims set to 50 milliseconds. Well, again, regular write are still affected to some degree while this removal takes place, but it's not that much, but still exists. Potentially, we might trade. We might try somehow a bit higher these higher periods to verify maybe. Well, I expect the drop the drop in writes even less. Well, that's all what I have for today. Thanks for listening. Any questions?
Thanks, Igor. Yeah, that's really interesting. I think a lot of the ideas you talked about which in the slides made sense in terms of the way to restructure things. I'm wondering about in these graphs about the large dip that you see at the end of the new procedure. Is that when you're doing the bulk remove?
You mean
like towards the end of where the deletion finishes for like the yellow and red lines? There's a drastic drop.
Yeah. Indeed, I observed some drops at this point. And honestly, I don't have a good enough explanation. Well, originally I realized that this record counting in RM range keys function caused much of it, but actually I haven't managed to remove it completely. So I managed to reduce this drop, but it's still visible sometimes.
Yeah, I imagine if you graph the client latency rather than average throughput, you'll see a very high effect there.
Yeah, maybe.
Yeah, the restructuring of the deletes makes sense in general to me. I think the part that's maybe more questionable is the remove range and the impacts it's having.
Yeah, I'm not completely sure that it worth doing all these bulk removals. But well, potentially it looks much much better. Well, so just run one operation and complete, but unfortunately RocksDB doesn't perform it ideally. Actually, I'm going to run some more experiments and have some better numbers. But so far, yeah, I agree, it's a bit questionable.
Okay.
Igor, I have a question. Can I?
Yep. Yeah, sure.
What do you actually do to object if you do operation that you named reclaim?
Well, for now, I perform touch plus truncate. Well, touch is actually redundant. It was introduced originally when I didn't have any content in the object and just had OMAPs. I realized that truncate is no op in this case, but finally I do some writes. I do 4K write in each object, so truncate is enough.
Okay, so the reclaim step is just that you empty all objects of the data with standard ops, objects store ops.
Well, for this POC, it's a regular truncate. For production, we might need removing. We might avoid on node resharding, since it triggers. It might trigger shard removal. Actually, we don't need it. But for my benchmark, it's since object content is trivial, there are no shards, and truncate is enough for me. And it doesn't suffer from shard removal.
Yeah, thanks.
Igor, did you also measure the CPU utilization during these tests?
No.
I think that's another effect that when Mark was testing remove range in the past, he saw drastically higher CPU utilization with remove range. So I'd be curious to see if that's the case here or not.
Yeah, and probably it's still there, but actually 2 points here. First of all, we have much less tombstones in this scenario, just order of order of number of placement groups. And second, as I said, there is record counting for current implementation prior to range delete calling. And now I'm bypassing it, but actually it could cause some overhead as well. Well, it definitely causes some overhead.
Yeah, no, I agree that those changes definitely make it more likely to work. But I guess to do more testing and see.
Yeah, but I agree that some overhead at RocksDB level might still exist.
The big
If I
thing that I
remember,
noticed is that it was the number of shoot, brain is blanking. Basically deleted keys, tombstones. There we go. The number of tombstones that really, as they accumulated, caused excessive overhead. So the amount of as soon as you did a compaction, everything got much better. But if you tried to do an RM range on a significant number of keys that didn't result in compaction, you could see really, really significant slowdown.
so Mark, remind me, the part about record counting only got added later in the RM range picture, right? In the initial implementation did not have any record counting. So
I don't think so, no.
Yeah, so we just added it because we knew that we had some performance results that showed that without record counting, RM range was not doing so well. So we wanted to introduce record counting to introduce a threshold, right?
Yeah, so if you're deleting a huge number of keys, the thought was that at that point maybe it's better. But I don't know that we really looked at what that value really is. We just set it arbitrarily high and then said, well, for now, let's avoid the really bad behavior and then kind of punt on figuring out what it should really be set to. So like right now, I think effectively we just don't use it because the value is so high. Does that make sense?
Yeah, I remember the part where we just increased the threshold to a very high number so that it's not enabled by default. But I'm just trying to think that what Igor is proposing is that if we remove the record counting altogether, just for the pool deletion case, would we see the same performance impact that you had seen when you had run the tests on just the base implementation of RM range without the record counting?
I think it completely depends on whether or not a bunch of tombstones are left around.
Yeah.
Without a compaction performed. If we compact immediately after we do the arm range, possibly breaking up the arm range into chunks and then compacting in between, we might be fine. But I think that if we just leave it to its own devices, hoping that we don't end up with a lot of tombstones left laying around, we may end up in the situation we were in before, possibly.
Mm-hmm.
At the very least, we should be careful when we do this.
Yeah, but it does sound like even if we leave the RM range part out, the other proposals that Igor made in one of his slides, those can incrementally be made, right? Like the delete sleep thing that he proposed, also about the collection listing. So I mean, I guess there's a lot of things that we can start working on immediately.
Definitely. The arm range thing is just one small piece, and there are almost certainly ways that we can work around it. I mean, it might even be good enough just to trigger compaction as soon as it's done.
Yeah, sorry, I'm back. My notebook lost all its power. So, yeah, one of the suggestions is to try some compaction after the removal indeed, and check if it helps to improve the things with all these tombstones.
Igor, you could also try to, in addition to doing it at the end, possibly breaking the arm range into discrete chunks and compacting in between, doing like 100 or 1,000 at a time with a compaction, between them.
Yeah, makes sense. But honestly, I have never tried this manual compaction from before. Well, I don't understand how it behaves from performance point of view, how it's applicable in parallel with the regular law on this store. But yeah, I will try.
Yeah, I don't know that any of us do. This problem isn't just one that we face. If you go out and look at the RocksDB archives for like the mailing list or whatever, there's you can't really look at the Facebook one, but there's like a Google group thing that you can look at. There's other people that have hit issues like this before. It's not super uncommon.
Okay. So, any other questions on this topic?
I don't have really a question, rather a request. Igor, is it possible to share the slides and the results?
Yeah, sure.
Like,
We'll do once power is on here again.
okay, thanks.
So we pretty much used up the whole time, guys, which is good. It's always good to have things to discuss like this. Should we schedule next week to continue the ONode discussion and move the paper off another week? Or do people want to talk about the paper?
I read the paper, and personally, I don't feel like it's that urgent. I mean, we can continue the discussion of ONode next week, and postpone the discussion of the paper. But
Okay. I'm okay with that unless anyone else has a strong opinion.
Sounds good to me.
All right. Sounds good then. So next week we'll continue the ONode discussion. Igor, thank you very much for your presentation. It was really interesting. I'm really curious to see what you uncover as you continue to work on this. And all right. Well then, see you guys next week. Have a great week, everyone.
Yeah, thanks.
Thanks, Igor.
Bye. Thank you.
Yeah.
bye.